This is going to be in the electrolysis lab. I have some papers here to help note down what I'm collecting. I have some beakers here that I'm going to use to sample stuff. And then I also have, I don't know what it is, but a new pack. Should have a new pack. A new one open. Yeah, there you go. Here we have indicator. This also lists the acidity of the solutions we're working with. As we produce sodium hydroxide with the baking soda, we should expect to see the solution become even more basic. It should already start off relatively basic, but it should become even more basic. And then we have a glass stirring rod here for whenever we finish our work. I will leave that on the paper. I'll be right back. I'm going to set up everything. Yeah. So here I have a 100 milliliter beaker. I'm going to try to get 3 moles of water in here, which is approximately 54 grams, which is also 54 milliliters, if I am correct. Yeah, I'll check that out right now. It should be 54 milliliters, yeah. So I'm going to fill this up, and after that I'm going to measure maybe 1 mole of sodium hydroxide, or not sodium hydroxide, sorry, baking soda, which is sodium bicarbonate. So now in theory, some of the sodium hydroxide should react with hydrogen ions produced at the anode, I think. And also, I'm using copper and graphite as my electrode. First, for the experiment, I want to just use let's see, solution happens at the anode, which would mean, yeah, I want to swap electrodes because I want to dissolve some copper too, but I want to be careful on how I do it. I want to know what's going on. In all honesty, I'm just goofing around. So, glove sucks. Well, the reason I'm using sodium bicarbonate instead of salt is because salt creates chlorine gas, and I want to do this experiment indoors. All that this experiment creates is oxygen, hydrogen, and carbon dioxide, and as long as there's no sparks nearby, I should be okay. So, yeah, that should be it. Now here I do have some acetic acid. This is just in case the solution does become neutral, or I'll add some. And I do want to collect some sodium hydroxide from this, but if I ever change my mind, I could just put some acetic acid in here and I'll be able to dispose of it. Because you want to neutralize the solution before you do that. And then the only thing that I really need from here on out is probably going to be a waste beaker, which is going to be right here. I'm going to use this to put my waste in. And by waste, I really just mean if I clean my glass stirring rods with water, by pouring water on it, I'll want the water to fall in here. And that's not a really good practice, but this is a pretty basic experiment. So nothing bad should come out of it, hopefully. Let me just make sure I have everything I need. I'm going to get another beaker here and fill this one with water for dilution. So I'm just going to write down water here. Now I do want to note that the water I'm using is hard tap water, so that might affect how well things work. It might give some precipitate in the electrolysis solution, and that's okay. I'm just here to test things out. I want to take some pH tests, so I have some paper already separated here. I'm going to place this paper on the napkins here, so that way I don't get anything on the wood, because you don't want that. Waste beaker is going to go over here. I'm going to put down my multimeter, because I'm already aware that the batteries I'm using work pretty well, and I don't want to get anything on it. Put them here. Yeah, I'm going to get some water in this, and we'll start. So I do approximately have 100 milliliters of water, which should equate to 100 and grams of water. So it's this here. Yeah, there's an extra 100 grams. That's just because of the beaker, which, you know, it's pretty heavy. So I'm gonna place our paper boat here, or a waiting boat. I don't know how much sodium bicarbonate I do want. I'm going to put around, let's see, we have, if I'm correct, around 54 grams of water in here. So I'm gonna try to balance that up with like maybe 30 grams of sodium bicarbonate. It has to be a very electrolytic solution. Okay, this is not coming out that well. Okay. Okay, this is coming out at 13 grams, 14 grams. It's not as much as we wanted, but we're just testing things out here. And I don't want to create something that's too conductive. If it's conductive enough, it works. Let me get this evened out. Scales off, we have everything we need. So I'm going to put this under a piece of paper, just in case. So this is the solution we'll be working with. We have our alligator clips here. One of them has a copper electrode and the other one has a graphite anode. I'm going to keep these separate because you don't want to short circuit your battery. It's going to be right here. I'm going to place it like this, or no, like this is probably better. And I'll be right back. I'm just going to make some final, actually I'm going to pour this into here and dissolve it, and we can check here the final basicity of the solution once we mix it. We do have some leftover bits, but that's okay. That'll go into our little trash can over here. Let me dissolve this. So this should be relatively conductive because sodium bicarbonate is an ionic compound, and when you dissolve it in water, electrons are able to flow freely between the two. So I'm not going to stick my multimeter in here because we already know it's going to be conductive. We could get a sample here and we could put some onto this litmus paper, and we'll find out that it actually is quite basic. Just if I could separate this. It really is just one finger. It's weird. Whatever. So here we have our litmus paper. I'm going to put a little bit on it. As you can see, it does become a little blue. This indicates a pretty basic solution. Its basicity is right about 9 to 10 pH, which means that it has a very big lack of hydrogen ions. Put this over here to my waste bin. Now I'm going to stir this just a little bit more. It's not fully dissolved yet, but that's okay. And then we'll place in our electrodes. Before I do, I just need to make some confirmation checks. Make sure I'm putting the right electrode where it is. Because I don't want, for the first run, I don't want the copper to get oxidized. So, okay, so according to some notes I took earlier, the anode, positively charged anode, is going to undergo oxidation, which essentially just means that the metal that you're using for the anode is going to get oxidized and go into solution. So the anode is going to be the positive end of this battery here. So for the positive end, we're actually going to want to put a piece of graphite, because the piece of graphite is essentially going to let us know that it's not, because graphite is inert, so it's not going to get into solution. And if it does, then I guess I'm wrong, but we learned something new. So here I have my copper. And with that, I think we are ready. If some explosion does happen, I'm sorry, future Mario. But science, I guess. Okay. If only I could get this thing to start working. Okay. So here we have both of our. God, bro, I'm kind of scared. We do have some. I don't know if you saw that, but there was a fizzing coming from there. The battery is not really that warm. But as you can see, we do have electrolysis. See right there, that right there is hydrogen and oxygen bubbles, as well as carbon dioxide. I don't know if you hear the fizzing here. That's that. So that is electrolysis of graphite. Now, what's happening is a hydrogen is forming at one electrode, and at the other electrode we have hydroxide ions. We also have sodium hydroxide forming. So that's kind of just a mix of things that are happening at the same time. If we mix this again, just, I think it's already saturated, but if it's not, it should be now. Put this down here. Okay. So let's do a pH test on it again, because I'm kind of curious now. I want to see what it turns. I don't know if you saw that, but there was some clear fizzing in that solution. I was kind of scared. pH paper in. So this is the earlier pH. This is the current pH. It seems a lot more basic, I think. Well, actually, no. It seems a little less. Look at that. So I have my electrode here. Oh well, some dye got lost in there. I have two ends of the same solution. I really should get some liquid pH indicator, because I feel like that could be pretty useful. So, for recap, this is the anode, and the anode is where oxidation happens. But since graphite is inert, graphite particles aren't necessarily being lost into the solution, so nothing's really getting contaminated. Here, there's an excess of electrons, which means that the copper won't really get put into the solution. And then what will happen is, I think, since this is a negative side, negative particles like oxygen are attracted to it. We could do this again here. We could see that there are smaller particles Yes, there are smaller particles forming. You seeing these bubbles form? It's pretty cool. Wow. So we do have that happening. Keep this away from the last run. I'm gonna get two ends of this pH paper. One dip in here, and the other dip is going to be on the other side. Actually, I should just use a pipette for this. I don't know why I'm doing all that. So as you can see, one side is a little more acidic than the other. They're both pretty basic though. I assume that's because they just react instantly, because there's no membrane separating the two. So they're just reacting and canceling each other out. I mean, an overall basic solution. It doesn't get more basic, but let's see what happens if we swap the electrodes, copper, and the other electrode here of graphite. Because in theory, doing that would mean that now the copper electrode is getting oxidized, which means that it's essentially losing all connection to the copper and just falling into solution. Let's see what happens if we do this. God save me if something goes wrong. So here we have the reaction happening again. If we keep this running, in theory, the solution should become purple or bluish. There is some blue forming out here in the solution. It's pretty interesting. So one thing you might notice now is that the solution looks vaguely bluer. This is actually copper going into solution, which I think is pretty cool, how you could just dissolve copper like that. If you could dissolve copper like that, you could dissolve essentially almost every other metal. I'm going to bring this camera a little closer up front, that way you can... Actually, I'm going to move this a little closer up front for you. How about that? I'm going to stir this up real quick before we continue, because I really want you to see this blue that's forming. I think it's pretty cool. I'm just going to mix that up here with the copper. I think this sodium bicarbonate, dissolved sodium bicarbonate, and the copper might react, but that's beyond my concern right now. I just want to see the copper get dissolved. So as you can see, this copper wire here doesn't necessarily look thinner, but it looks a lot newer. There was a layer of oxide forming on it, but now that I've put it into the electrolysis chamber, the copper ions are going off, so we had a fresh layer of copper at the front. So I'm going to put this back in here. You'll see the fizzling. Now you might notice that the water is getting bluer. That is the copper. Look at that. You can see the copper leaving the solution. That's pretty cool. Look at that. Wow. That's awesome. Wow. Solution is getting bluer. This isn't necessarily a measure of basicity because there is no liquid indicator in here. This is all copper that's getting dissolved, which I think is pretty awesome. Oh, look at that. Wow. And you can leave this running for a good bit and your solution will be very blue because of all the copper that's getting dissolved. I just don't want to let it run because the thing is, if these electrodes come into contact with each other, nothing happens. And you actually short circuit the wire, which is not what you want. So you might notice our water is now getting very blue. It's almost like a blue raspberry type of thing that's going on. I'm going to take these electrodes out of the water. Now, look at this. This is pretty cool. If you look at this copper wire, you'll notice that you have normal copper, and then you go down here, and there's just this weird layer of something. We don't know what it is. We can do a pH test on it. As you can see, our solution is very basic. You want to be careful. You want to handle this with gloves. If this touches you, it could be pretty bad. Running a pH paper over it. It's not necessarily... It's pretty basic, but it's not a strong basic per se. This is on this end of the paper. You can see here it's kind of vague. But there is something forming on this. Now, you could try to guess what it is. I'd assume it's probably just the baking soda. That's not dissolved yet. I just put this in here, wiggle it around a little bit. It doesn't seem to get clean, so it's actually corroding in a sense. You hear fizzing coming from it, which is pretty cool. So here we have our copper solution. Now, I'm not necessarily sure what you could do with the copper solution, but it's pretty cool because copper we know as something that's a reddish color, but all of a sudden you dissolve it and it becomes blue. Once you just take out 2 electrons, it becomes blue, which I think is pretty interesting. Kind of says a lot about how light is made from electron levels. Now here I have some acetic acid. We could test the pH of this acetic acid. I'm gonna get some more litmus paper for us. Hopefully I don't contaminate it. I do not want my litmus paper to be contaminated. It's been going on for 15 minutes. It's a pretty lengthy experiment. So here I have a whole bunch of litmus paper. Probably not going to use all of it. So here's our acetic acid. Hold on. Do I really have more paper in here? I don't know. So here I have my acetic acid. pH paper goes in, pH paper comes out. As you can see, it is acetic acid. It's acidic. Acetic. I'm gonna get a little bit of it with my pipette. I want to make a small micro reaction here. I want to see what happens if get my mini beaker for tests. So here we have a little mini beaker. I'm gonna get a little bit of both solutions. So here we have the basic copper solution. I'm gonna stir this around a little bit more. Basic copper solution. So here's our basic copper solution. Pour just a little bit. This is like 1 milliliter. Yeah, 2 milliliters now. So I have 2 milliliters of the basic copper solution in this tiny beaker here, which I'm gonna place right here. So there is a little bit of precipitate on this, but I think it's just contamination. You could get a pH paper, right? It's the same solution from earlier. Just drop a little bit on it. You see it's basic, right? So this is going to be the basic solution. I mean, the acidic solution. And we have, I can't necessarily tell you the molarity of the base in this, but that's too much paperwork for me right now. We get some acetic acid though, pour it in here, and you'll see an acid-base reaction, which is pretty cool. So here I have some acetic acid in this pipette. Pop some. You don't want to put too much. Oh, it fizzes. You see, look at me. Did you hear that fizz? I heard it. So that's why you don't want to add too much at once, because this does generate some heat and it does generate carbon dioxide gas. I think it should create carbon dioxide gas. But now we kind of mix this solution here. You'll see we can test the pH of it with the paper. See what it gives us. Yeah, I don't want to use a. I'm gonna use a new pipette for this because I don't want to contaminate anything per se. Here's a new pipette. So we have our new pipette here. We're gonna get just a little bit of it. We're gonna plop it down on this piece of litmus paper. So as you can see, this is the earlier pH right here, and this is the new pH. It's still pretty basic, but you can see that there's a big drop in the basicity of this. So there is some acid that's reacting here. This video doesn't really have any inherent purpose other than tell you all the cool stuff you can do with electrolysis, because we have some copper that we just dissolved. Usually you can't just put copper in a piece of water and expect it to just dissolve this quickly. But by passing some current through it, you can, which I think is pretty cool. Let's react some more acid with this till we get a look at all that carbon dioxide coming out. Should be carbon dioxide because we do have still some baking some baking soda in here, some sodium bicarbonate, and sodium bicarbonate should release carbon dioxide, because I do whenever we scroll this up before we put it into our little testing beaker. Let's run another pH test. Oh, whoa, something happened here. Hold on, take a look at this pH at this litmus paper. Looks like pH hasn't changed that much. Still the same. It's a little less basic. I think it's because this acetic acid isn't necessarily strong or as strong as the base. It's 5%, which is good enough. It's cooking grade. It's not necessarily lab grade. So we're gonna have to put a lot of it in here to dilute it. Also, want to keep in mind that there is salt in this solution, which kind of contaminates it. I'm gonna add it drop by drop. Let me see. Let me hear that fizz. You hear that? These are gas bubbles that are forming. They shouldn't be inherently dangerous. We're just gonna keep on dropping this in here until we stop hearing. Oh, look at that. When you mix it, there's a bit of fizzing. I think that we're making carbonic acid. I could be very wrong, but it just makes sense to me because you have acid in here that you're neutralizing with the base. I'm sure that makes water, but I mean, you do have hydrogen ions and you do have carbon dioxide from the carbonate. So it seems as there's no more fizzing here. Everything's reacted fully. We can test the pH of this liquid now. We're gonna get another okay. So it looks like it's fully reacted. So here we have our pipette. I'm gonna put this on this litmus paper. Oh, it's acidic. Look at that. It's basic. It's acidic, but it's just barely acidic. It's not as acidic, so it's mostly neutral. I give this around a pH of let me see. The base is the neutral was 7. This is probably going to be a pH of 6 or 5. Not necessarily dangerous. You could probably drink this, but I wouldn't recommend it. But here we have our solution. As you can see here, they are pretty different in color. I would say that's just because there's different solutions, like different amount of everything here. But you can see that we do have some excess baking soda here. Let's see what happens if we get some of this baking soda and drop it into our slightly acidic solution. I'm gonna leave this on the table because I don't want to. Ooh. Did you hear that fizz? Look at that. It's a lot of carbon dioxide that's forming up. Let's add just one more drop because I'm kind of scared now. I want to let you know that this solution right here is very strong, especially since we've collected it straight from the bottom where it's the most concentrated. So we do expect a strong fizz from this. Let's collect some of this bubbling solution here. Let's drop it onto our pH paper, and that gives us something that is acidic. Yeah, it's still pretty acidic. Let's try neutralizing it some more. This is why you really want to have some liquid indicator solution, because then you can save yourself from all this hassle. Drop a little bit more. There is some precipitate that's forming on top of all of this, which is pretty cool. There's a black particle coming from underneath this. I don't know if you can see it, but there's some black particles. This is probably just a copper coming out of solution, but I wonder how. So here we have some solid. We actually have some solid sodium bicarbonate at the bottom here that's just kind of reacting with the basic the acidic solution. It's pretty interesting. It's just bubbling. It's producing a lot of. Oh, it's just the vinegar. It's producing a lot of whatchamacallit, CO2. It's pretty interesting. So I have a solution of of copper, dissolved copper, and I don't really know what to do with it. So if you guys have any ideas what I should do with the copper bicarbonate solution. Not copper bicarbonate as in their molecules, as in they're all kind of just dissolved. I have to extract this here from the solid sodium bicarbonate at the bottom. So I think I'm going to pour this into a separate beaker. Really quickly though, I'm going to try to neutralize this solution, so wish me luck. I think it stopped. Oh, there's still some more, but maybe I just have to mix it up a little bit. Okay, so it's mostly canceled out. I'm gonna get another pipette here. It's neutral. It's been neutralized like that. Look at that. It's been neutralized, the solution. So I'm just gonna pour a little bit of this bit by bit. We should not get that much of a reaction from this, because for one, this is just whoa, that's so cool. Check this out. So we left the copper solution, we left the copper electrode out of this for a bit, and look at this, it's already sort of corroding in its own unique way. This is pretty cool. See if it's gonna do anything once we put it back in the solution. So if anything, we kind of just sped up the process of corrosion for this copper, which is why I want to be careful whenever you're selecting what you're going to use as your electrode and your cathode, because it really varies by purpose. Oh, do not want to have that happen. Okay. God, this is really embarrassing. I gotta get some new alligator clips because this kind of just sucks. Come on, man. Oh, yep. Copper is touching the wire now. Okay. God. Bro, just stay attached. Come on. Okay. So you can see our graphite rod is practically untouched. It's a little darker on this end here for me, this graphite rod here, but it's not necessarily something noticeable. Let's put this back here. Reaction continues. We could keep this running and we'll have a very concentrated solution of copper ions. Oh, we don't want those touching, because that would short circuit your wire. So one thing I did notice is that in the solution here that we're making, the bottom portion, which is mostly now covered in some substance, doesn't necessarily react with the water as much as the top portion, which is kind of unexposed by layers. So, okay, that is our solution. So we do have some copper in here. I'm going to try to save this for later. You put some in a pipette and put it in one of these cups for later use. And I'll label it. So now we're just gonna extract everything that we got from this. Now, first of all, I probably don't want to get any of the sodium bicarbonate solids back down there. So I'm just gonna, okay, put these in the corner here. This is a pretty basic solution, so I'm gonna see how it works first with check the basicity of this. This does come off as a little basic. Yeah, so this is the current copper solution. It's pretty basic because of the sodium bicarbonate that's in there. But I wouldn't say it's as basic as it was earlier, probably because we did mix it in a little bit of acid in there. I'm going to, before I pour the rest of this in here, I'm going to get another beaker actually and try to separate either from the other. So here's our other beaker. I'm really using all the beakers for this. I'm going to try to pour a little bit of it in here. I'm going to wash all of these when I finish. Try to separate this from the stuff collecting at the bottom. Okay. So down here we have our sodium bicarbonate. It's not necessarily a strong base, but it can be if it's concentrated. So you want to be careful when you're disposing of that. And here we have our sort of basic dissolved copper sodium bicarbonate solution, which is also pretty basic, but in theory it shouldn't be as basic now that we've taken out a majority of the other. Yeah, it doesn't return as basic of a solution. Let's see here. Well, I mean, it is still pretty basic, but another thing that can't be fixed, especially now that there's no undissolved stuff in there. Let's see what happens if we just stick our thing in here. There's not really a reaction happening. Just makes sense. I don't know why I did that. So here we have our copper solution, which is pretty cool because now we have dissolved copper. I never knew you could do this until a while ago. So just pour that into our beaker here. Hopefully this basic solution doesn't react with anything in here. Look at that. Evelyn, olha aqui. So that this is the, I think this is some form of copper oxide on it. If it's not, if anyone knows what this is, y'all could tell me in the comments. I would really much appreciate it. This is like a blue layer on top after using it as a anode, I think. Yeah, an anode. I'm gonna compare these results with my cousin real quick. So here we have our copper solution. I'm gonna label this somehow. Yeah, so here we're copper. I'm gonna mess around with this a little bit. If you guys have any idea of what I could do with this, that would be pretty nice. This is also probably pretty conductive because it does have sodium bicarbonate in it. So I could probably use this to electroplate some things in actuality. I'm not necessarily sure what salt this makes whenever you put it back out of solution. It might make copper bicarbonate, but I would really appreciate it if you guys could tell me. I know there's a lot of geniuses out there on the internet. I don't really know what I created, but I do know that there's copper in here, which is pretty cool. I'm going to label this as a copper sodium bicarbonate type of solution. Warning, basic. And I'm going to really quickly dispose of all this stuff. I'm going to get a little bit of this, pour some vinegar in here. Ooh. As you can see, that creates a great deal of carbon dioxide gas. Look at that. It bubbles over like that. That's pretty cool. So you want to add things very slowly when you do this. Okay. I'm going to dispose of these outside. I'm going to dilute it with some water first. So now you want to pour this into the water because you don't want to ever want to pour water into a base or an acid. It's always the other way around because then you can get acid spills. So it's going to be your cleaning beaker. To clean these, clean this. Acetic acid in here. It makes some carbon dioxide, but no big deal. Alright, well that was the lab. I'm going to go clean up this mess. I'm going to post this on YouTube. Let me know if I'm dead. Bye.